Welcome. So this is a projectile motion problem. The problem says that a cannonball is fired at 15 meters per second off of a cliff, horizontally off of a cliff. And it takes 3 seconds for the ball to hit the sea. And it wants to know what is the speed of the ball as it hits the water. So we're talking about a speed, which is a magnitude. But that speed, if we imagine this portion here, the ball's coming down, and here's the water. We'll just draw the water like that. That speed is made up of two components. There's going to be a horizontal component, VH, and we can imagine a vertical component, V vertical. So what we do is we would use Pythagoras to figure out what the speed was, what's called speed v. So that's the game I'm going to play. I'm going to find a horizontal final velocity. I'm going to find a vertical final velocity, and I'm going to combine them to get my final speed. Something's bugging me on this, and it's just a small point, but I don't like to leave it like this. When you do components, try to make the components look right. So if that's the final speed, which is a velocity in that direction, then the horizontal component should reach the end, be in line with the end of the velocity vertically, and vertical component should be lined up with the end of the velocity horizontally. Okay, so if I want to find some horizontal information, let's use horizontal information. So because I'm looking for several things here, I'm going to say find VH using hor inf. And I'm going to say, well, horizontally, VI is equal to plus 15 meters per second, because that's how fast it's going sideways. Going to the right, so it's positive. And A, and we know the horizontal acceleration is 0 meters per second squared. It's not minus 10. And we know that our time is equal to 3 seconds. And I want to find my V final. And I can say VF equals VI plus A delta T. So VF is equal to plus 15 added to 0 times 3. VF, I'm going to put down horizontally, is equal to VH, which equals plus 15 meters per second. There's my first bit done. Now let's have a look at my vertical bit. So let's go to a red pen and say find VV, the final vertical velocity using vert info. So I say, well, VI vertically. Well, if we look up here at the start of my journey, the initial vertical velocity is 0 meters per second. And my acceleration is equal to minus 10 meters per second squared. And again, my time, my hang time, my duration is equal to 3 seconds. And I want to find my final velocity. And again, VF is equal to VI plus A delta T. So VF is equal to 0 plus minus 10 times 3 VF vertically, which equals VV in our terminology for today, is equal to minus 30 meters per second. Now let's combine these. And what I can say is V squared is equal to VV squared plus VH squared. It's just using Pythagoras. This is a right triangle. We can use Pythagoras. So we can say V is equal to the square root of VV squared plus VH squared. So we can say V is equal to the square root, and my VV is minus 30 squared added to plus 15 squared. My VH was plus 15. So V is equal to the square root. 30 times, well, minus 30 times minus 30 is plus 900. So that's going to be 900 added to, and 15 times 15 is 150 plus 75, which is 225. So V is equal to the square root of 1125. So V is equal to, I just go to my handy dandy little calculator and I go square root of 1125. So that equals, and I'm getting 33.54. So this is equal to 33.5 meters per second. I don't need a sign in front of it because it is a magnitude, it's a speed. So it is by default positive. And we look over here and we say, 33.5. At least it's one of my answers, so that's a good sign. So we analyze the problem and we recognize that our speed would be given to us by knowing our horizontal final velocity and our vertical final velocity. So we set about finding those two things. For the horizontal information, I used horizontal information. For the vertical information, I used vertical information. Having found those two velocities, I visualized them vectorially, and then I used Pythagoras to solve. And there we have it.